Okay, so for question 2, there are a few information given here. A is 104 meters, okay, from C on a bearing of, okay, 64. A from C. So let's label that A from C. So at C I have the north line, okay, and the angle is clockwise. So this is 64. Okay, next I have B is 135 from C. So B from C is 112. So B from C, okay, so B from C, I have that north line there already at C. The angle for this one is 122. Okay, 122. Okay, so with that, there's a hidden information here. I can actually find with those two angles, this one, this angle ACB. Okay, so work out angle ACB on your own, and in part A, you're supposed to find the length of AB. Okay, since when I look at this triangle right now, let me redraw that here. Okay, I don't have AB, I have 104, 135, and I have the angle inside. Okay, so since there is no one pair of length and angle, no sine rule. Okay, so part A, I must use cosine rule. Alright, so pause the video now and work out part A on your own. Okay, so part A, you should obtain the answer as 119, okay, meters to 3 significant figure. Okay, let's take a look at part B now. Part B, you're supposed to determine the bearing of A from B. Okay, so A from B, okay, I need to have that north line. Okay, so here is where I need to find the angle that is clockwise. There you go. Alright, so what I can see here is that I have 122 here just now. Okay, so angle between parallel line, I'm able to actually calculate this whole angle here, because this angle here is 122. Angle between parallel line add up to 180. Okay, so if I take 180 minus 122, I can get this. But the challenge is, okay, you are supposed to actually calculate this small portion here. If you're able to get that small portion, let me label that as X. If you're able to get X, 180 minus X will be the bearing. Okay, so now the problem is the green part contains X and this extra angle that you do not want, angle ABC. Therefore, after finding the green angle, you must find angle ABC so that you can subtract off this angle to find angle X. Okay, so I leave that to you. Okay, can you find angle ABC? So part B, your mission is to find angle ABC after finding 180 minus 122. Okay, the answer for part B will be 349.8 degree. Alright, so pause the video, attempt B on your own. Part C. A boat T travels in a straight line from C, so from C here, all the way towards the line AB here. Okay, so if it travels in a straight line and you are calculating the shortest distance, the straight line cannot be just any random straight line like that. Okay, the straight line, if it's the shortest distance, it must be perpendicular to AB. Okay, so this is the distance that I'm finding. Alright, so let me label that as X. Okay, so how would you calculate that distance? So to calculate the shortest distance, there are two methods. Okay, first, I'll show you the first method. Method 1 is to actually identify the right angle triangle where you can use t3w8. Okay, so I will identify this one. Okay, so if I look at that triangle, here is 90 degrees. I am trying to find, I can use this angle here, okay, which you are supposed to go and calculate. Since previously you have found this angle, okay, and this angle, you can find angle CAB. So method 1, first find angle CAB. Second, okay, I look at that triangle, I notice that if I want to use t3w8, 104 is hypotenuse, opposite of 90 degree, and X is opposite. Okay, so I use sine theta equals to opposite over hypotenuse. Sine angle CAB equals to X over 104. Okay, so sub in the angle CAB, which you have found just now. Okay, your value should be 58. Alright, so sub in sine 58 X over 104 and find the value of X, the shortest distance. Okay, since X is not given in the question, make sure you start off by stating, let X be the shortest distance. Okay, alright, so that is how you do part C using method 1. Now method 2, what you do is you use area of triangle method. So let me state method 2 here. Method 2. Okay, how to find area of triangle? There are two ways. First, I already have these two lengths. I already have the angle just now. Okay, so I use half AB sine C to get the area of triangle. What is the value? Next, at the same time, I know that, okay, to find area of triangle, I can use half times base times perpendicular height. So if this is the perpendicular height that I want to use, the base will be here. Okay, base AB I've already gotten just now in part A. So this area will be equal to half times AB times perpendicular height that I'm trying to find. Okay, so area I have already, half times 119 times perpendicular height. So find the perpendicular height using this method. Okay, so your answer will be 88.2 meters for part C. Okay, we move on to part D. C is a point at the base of a vertical cliff. So D is on top of the cliff. So C is at the bottom. Notice that ABC is on the ground floor. So now part D, is going three-dimensional. Okay, so which means now they say that D is the point on top of C, angle of depression of B from D. Okay, B from D. So notice on the ground, this question part D is identifying 2 points on the ground, C, B. So what I will do now is I will redraw C and B to be ground level. Okay, they are ground level and the length is 135 meters. Now, point D is vertically above. Therefore, I must draw D to be vertically above. Okay, so that's why I cannot draw on the original diagram because now this is three-dimensional. So this on top, perpendicular. So next part, angle of depression of B from D. Okay, angle of depression of B from D is given as 27 degrees. So angle of depression is always horizontal line down. Okay, so that part there is 27. Okay, and I can see that since the horizontal line is parallel to the one on the ground, this angle here is also 27 degrees. Can you use that to find the height of the cliff here? Okay, use your tuakaso. I'll give you the final answer. Final answer is 68.8. Okay, 68.8 meters.